Let's continue our lecture video discussion in Differential Calculus under the subtopic Application of Maxima and Minima. Let's continue in example number 6. The sum of two positive numbers is 4. Find the smallest value possible for the sum of the cube of one number and the square of the other. So, applying the steps that we have learned in the previous video. Number 1 is identify the constant. The constant here in this problem is the sum of the two positive number, which is 4. Next, identify the variable to be maximized or minimized. So here, what we are minimizing or looking for the smallest value is the sum of the cube of one number and the square of the other. So S, or the sum, is to be minimized. Next, step number 3, express this variable in terms of the other relevant variables. So, sum here, the sum S that we need to be minimized is, so the sum of the cube of one number, say x, sum of the cube of one number, so let x is the one number and y is the other. So the y here is the square y. So this is now our equation number 1. Now since we have here two variables involved, x and y, we need to have another equation so as to equate later on. So we can use the first sentence here, the sum of two positive number is 4. So we have there x plus y is equal to 4. And this becomes our second equation. Next, step number 4. Okay, so we're done with that. Step number 5, differentiate and equate to 0, the one being minimized. So we have there ds over dx is equal to 0 for least sum. Okay, so next here is we will differentiate equations 1 and 2. So differentiate equation 1, then we have there s is equal to x cubed plus y squared. Since ds over dx is 0, so this is equal to 0. This is 3x squared plus 2y y prime. 2y y prime is equal to negative 3x squared. Y prime is equal to negative 3x squared all over 2y. So that is our y prime for equation 1. Next, differentiate equation 2. Our equation 2 is x plus y is equal to 4. This is 1, derivative of x is 1, dx over dx. And this one is y prime equals 0. Y prime is equal to negative 1. Then, let's continue in this space here so that we can maximize the space. Equate y prime. So we have there y prime 3x squared over 2y is equal to negative 1. Cancel the negative sign. So what's left is 3x squared equals 2y. And if I want to get the value of y, then this is equal to y equals 3x squared over 2. Next, what will we do with this equation? Now, this is actually equation number 3. Now, what we're looking for is the value of the sum. So we are looking actually for the sum of this one. So in order to get the value of this s here, we need then to first find the values of x and y. So how will we do that? So one equation that has a constant is equation number 2. So let's substitute what we got here, the equation number 3, into equation number 2. So let's use the other page. Substitute equation 3 to equation number 2. Equation number 2, and that is x plus y is equal to 4. And the value of our y is, or the equation y is, so x plus 3x squared all over 2, that is equal to 4. Then we have there 3x squared, or this is actually, you can have it as 3 halves x squared plus x minus 4, that is equal to 0. So we can actually find the values of x using the quadratic equation. Take note, we're looking for the value of x and y in order to get the value of s, or the sum. So using quadratic equation, we have there, so the equation first for that, over 2a. Now this is our a, this is our b, and then this is our c. Input the values, negative 1 square root of 1 squared minus 4. A is 3 halves. C is negative 4 all over twice of 3 halves. So therefore, we have there values for x1 is 4/3. Value for x2 is negative 2. So there are two values for x. Which one are we going to use? Now going back to the problem, it says there the sum of two positive numbers. So meaning x and y is positive. Therefore, we will then use the value of x here, which is positive. So we will use this one. Next, substitute for us to get a value for y. Substitute x1 to equation number 3. So we have there y is equal to 3 halves, and then that is x squared. 4/3 squared. So y is now equal to 8 over 3. So now, finally, we have two values for the sum. So substitute now. Substitute x and y to equation 1. S is equal to x cubed plus y squared. S is equal to 4/3 raised to 3 plus 8 over 3 raised to 2. And the value for this is 256 over 27. So we can have that answer, or if you want a decimal, 9.48. So that's what the problem is looking for. So that's for example number 6. Okay, for example number 7. So for example number 7, a normal window is in the shape of a rectangle surmounted by a semicircle. So at least the problem is describing how the normal window looks like. So a normal window is in the shape of a rectangle surmounted by a semicircle. For a given area, what proportion gives minimum perimeter? So if ever in the case is the problem did not describe what a normal window looks like, so take note that normal window might looks like this. So a rectangle surmounted by a semicircle, which you can observe in some churches and castles or some universities. Okay. So here are the examples of Norman windows. So look at that. So it has a semicircle on top, and then below that semicircle is a rectangle. So going back to the problem, so we can use that drawing here. Then let's put a dimension. So let's say this is x here, this is x, and this is y. Now if this is x here, so what will be the radius for this semicircle? So since the area, the line here is the diameter, therefore the radius here is 1/2 of x, or that is x over 2. Okay? And of course this is also y. Okay? First step, identify the constant. So what is the constant in the problem for a given area? So it says there, for a given area. Therefore, area is constant. Next, identify the variable to be maximized or minimized. Then, what variable? The problem is looking for the proportion to give the minimum perimeter. So we're looking for the minimum perimeter. Oh no, we're looking for the proportion. So we're looking for the proportion to give the minimum perimeter. So the one to be minimized is the perimeter. To be minimized. But the problem is specifically looking for a proportion. So when you say proportion, it's the comparison from one variable to another. So to be minimized, number 3, express this variable in terms of the other relevant variable. So if this is p here, so and then we have two variables x and y. So the relationship here is that perimeter is equal to perimeter means the measurement of the outside boundary here. So the white line there, the white line. Okay, that's the perimeter. So let's start with y plus x plus y plus the half of the circumference of the circle here. So half this circumference of a circle. So we have twice of y plus x plus 1/2 of the circumference of a circle. So we have there it's 2 pi r for the circumference of a circle using radius 2 pi r. Now what is the radius in our figure? So our radius is actually x over 2. So cancel 2, then there's still 2 there. So plus pi over 2x. So perimeter is equal to 2y plus x plus pi over 2x, and that is equation number 1. Now since we have two variables here, x and y, if the function shall consist of more than one variable, then we will be looking for another equation. So what equation can we use based from this figure that contains also the x and y variable? We can use the area. So area is equal to the length times width plus 1/2 of the circumference, 1/2 the area of the circle. Area of the circle is pi r squared if we're using the radius. Now area is equal to the length is say x or y, or x and y, it's still the same, plus 1/2 of the pi the radius is x over 2 squared. Area is equal to x, y. So 1/2 of, so 2 times 2, that is, no, x squared. It's x squared over 4. So area is now equal to xy plus pi over 8 x squared. This is now the equation number 2. Next, number 5, differentiate and equate to 0 the one being minimized. So the one being minimized here is p, dp over dx. It's equal to 0 for minimum perimeter. Next step is to differentiate equations 1 and 2. So differentiate equation 1. For equation 1 is p is equal to 2y plus x plus pi over 2x. Then since dp over dx is equal to 0, then let's say 0 equal to 2y prime plus 1, then plus this is pi over 2. Okay, so we can still manage that. 2y prime equals negative 1, negative pi over 2. Then we have there 2y prime is equal to negative 2, negative pi divided by 2. Y prime is equal to negative 2, negative pi divided by 4. And that is our or we can just put the negative sign also. So that is the y prime for equation 1. Next, differentiate equation 2. So we have there differentiate equation 2. Our equation 2 is there. We have there area xy plus pi over 8 x squared. Then since the area is constant, so from the problem a is constant, therefore we have there 0 equals x y prime plus y times 1 plus pi over 8 times 2x. 0 equals x y prime plus y plus pi over 4x. xy prime, negative y, negative pi over 4x. xy prime is equal to, this is 4, negative 4y minus pi x. Therefore, y prime is equal to negative 4y plus pi x all over 4x. So that is our y prime for the second equation. Then let's equate. Equate y prime. The first y prime is negative 2, negative parenthesis 2 plus pi all over 4 equals negative parenthesis 4y plus pi x all over 4x. Cancel the negative sign, cancel the 4, so what's left is the x. So x 2 plus pi equals 4y, because we have already cancelled 4, so cancel here, and the negative sign, cancel 4. And then we have plus pi x. Distribute, we have 2x plus 2 pi equals 4y. It's not 2 pi. Pi x plus pi x. Then this pi x here can be cancelled already, because if we transfer this here, it becomes minus or negative pi x. Therefore, what's left here is 2x equals 4y. Therefore, x is equal to 2y. So what the problem is asking is the proportion. So what's the proportion? So the proportion here is that, so y is length. So the width is equal to the twice of the height. So we draw that. If that is the case, so previously we have there this is x over 2, and then this is y, this is x. Now having the value for the x, we have there 2y, that is 2y. Therefore, what is the height? The width of the normal window is 2y. What is the height of the normal window? So x over 2, meaning this is y, and also y there, because if you look at this, x over 2 is equal to y. Therefore, height of the normal window is equal to width. That is, if we do this proportion in building a normal window, then it gives the minimum perimeter. Okay, so that is for example number 7. Also have this answer also, okay? So we'll accept that. X is equal to 2y. Okay? Next, sample number 8. Find the most economical proportions for a quart can of height h and diameter b. diameter d. The first step, identify the constant. So what is the constant in the problem? Well, there is none. There's no constant here because the h value will change and the d value will change for us to achieve the most economical proportions. So that is the case. What is the variable to be maximized or minimized? In this case is economical proportions, meaning we're looking for the minimal proportion for it to be most economical. So what variable is that? If d and h change, how does it affect the quart can? What is being affected in the quart can? What is being affected if we change the values of d and h is the volume. Yes, it's the volume and the surface area. So not only the volume is affected, but also the surface area to be, say, minimized. Next, express these variables in terms of the other relevant variables. First, we have the volume. Volume is the area of the base multiplied by the height. So our base here is circle. So our base is circle, so the area for the circle is, using diameter, so we have there pi d squared over 4. Pi over 4 d squared. Then multiplied with height. So that is actually pi over 4 d squared times d height. And that is equation number 1. Next, surface area. So what is a surface area? So it is the area of the figure of the shapes that make up the figure. So if we cut that can, we will have two shapes. The first one is a circle, and there's two circles because this represents the top and the bottom base. Okay, then if we open or cut on the side here, just as you peel the label of a canned goods, then it will reveal a rectangular shape of height h, and the length will be, so what will be the length of this rectangle? The length is the circumference of the circle. So it's actually the circumference of the circle. And what is the circumference of a circle with respect to d? So it is pi d. If it is radius, then it is 2 pi r. If it is diameter, then it is pi d. Now, what is now the surface area? So for the surface area, we have there the two areas of the circle, 2 pi over 4 diameter squared, plus the area of the rectangle, which is pi d, or the length times width. And that is pi over 2 d squared plus pi d h. So this is SA equation number 2. Next, step number 5, differentiate and equate to 0. So we will differentiate and equate to 0 the ones being minimized. So dv over dx, we're not using x anymore. We are using variables d and h. So which one are we going to use? Well, you can have them, either of them. I prefer to use the h. So dv over dh. Also, derivative of the surface area, then dh is equal to 0 for most economical proportion. Okay. Then after this step 5, we will then go to the differentiate equation 1. So we have there v equals pi over 4 d squared h. Derivative of v over dh is 0. That is equal to pi over 4. And derivative of a product, we have there d squared 1 plus h 2d d prime. Why d prime? Because it is dh. This one is dh over dh. And then for the variable d here, it's derivative of d over dh. And that is d prime. Next, simplify 0 equals distribute. We will distribute pi over 4 d squared plus h squared. So we have pi over 2. Yeah, it is pi over 2 h d prime. Okay. And then we have there 0. No. Pi over 2. Well, let's keep the pi over 4 here. Pi over 4. We have there 2 h d prime. Okay. Then we have pi over 4 2h d prime, because negative pi over 4 d squared. Then cancel the pi over 4 there, and we have there d prime is equal to negative d squared all over 2h d, or d prime is equal to negative d over 2h. Next, differentiate equation 2. For equation number 2, we have there SA pi over 2 d squared plus pi dh. Since dSA over dh is 0, this is 0, equals pi over 2 2d d prime plus pi, so derivative of a product, d1 plus h d prime. So 0 is equal to pi d prime plus pi d plus pi h d prime. Then we have there 5d d prime plus 5 h d prime equals negative pi d. And d prime multiplied with, this is d prime, pi d plus pi h is equal to negative pi d. Therefore, d prime is equal to negative pi d all over pi d plus pi h. you can actually cancel the pi here. So d prime is equal to negative d all over d plus h. Then equate d prime. So our first d prime is negative d over 2h. Second is negative d plus h. Cancel the negative sign. So what's left here is d plus h equals d, or this is already, or d to h. Then cancel out your the d here. Then we have d plus h is equal to h. D is equal to h. So what is being asked again? The proportion. So what is the most economical proportion? It is most economical if the diameter is equal to the height of the container. So that is the proportion. Okay, so that is for example number 8. Next, we will now proceed to sample number 9. For example number 9, the sum of the length and girth of a container of a square cross-section is A inches. Find the maximum value. Now, before we proceed, what is girth? So, looking up in the dictionary, girth has been defined as a measure around a body. So it is the measure around a body. So it is then similar to the perimeter. So the sum of the length and girth of a container of a square cross-section. So imagine the container with a square cross-section is 8 inches. So we can have this figure. So if you measure the girth around this container here, so we are measuring this portion. 1, 2, 3, 4. That is around the body. If we put here x, then therefore the girth here is 4x. Again, what is the first step? Identify the constant. So the constant is the sum, which is 8 inches. So the sum here is 8 inches. Next, identify the variable to be maximized or minimized. So find the maximum value. So there goes the clue. B is to be maximized. Next, 3. Express the variable in terms of the other relevant variables. So B here is equal to the area of the base times height. Since the base is square, therefore this is x squared times the height. Let's say the height is y. So that is the volume, and that is the equation number 1. How about equation number 2? Because we have two variables, that is in the fourth step. if the function contains more than one variable, in this instance, it's two variables, then we were looking for a second equation. So where can we get that second equation? Going back to the problem, we can observe that there's already an equation here. The sum of the length and girth of a container of a cross section is 8 inches. So the second one here is length. So the length being mentioned is actually this portion here. So y plus the girth for x is equal to 8. Second equation. Third step, express this variable in terms of the fifth one. The fifth one is differentiate and equate to 0. The one being maximized. So we have there dv over dx is equal to 0 for maximum volume. Okay, next, differentiate equations 1 and 2. So equation 1 is v is equal to x squared y. So this is derivative of v is 0 equals x squared, then y is y prime plus y 2x. 0 is equal to x squared y prime plus 2yx therefore y prime is equal to negative 2yx over x squared then cancel out the x value here or the numerator. So we have here y prime equals negative 2y over x. Okay, next is to differentiate. So let's just put here differentiate equation 2, which is y plus 4x is equal to a. This is y prime equals to 4. Since a is constant, 0. Therefore, y prime is equal to negative 4. Next, equate y prime. So we have negative 2y over x is equal to negative 4. Cancel the negative sign. So what is left is 2y equals 4x. Y is equal to twice of x. And this is actually equation number 3. Now again, what is being looked for in this example, in this problem? Since they are finding maximum volume. To find the maximum volume, we need the values of x and y. So to get the value for x here, we substitute the value of, or we substitute this equation in equation number 2 in order to get a value of x in terms of a. Okay, so that's the plan. So substitute equation 3 to equation 2, which is okay, there we go, which is y plus 4x is equal to a. This is 2x plus 4x is equal to a. 6x is equal to a. Therefore, x is equal to a over 6. inch. Inch because there's a unit here for A is in inches. Next, substitute x to equation 3 to get the value for y. So y is equal to twice of x. So y is equal to a over 3 inch. Then for us to have now the value for volume, substitute x and y to equation 1, which is v is equal to x squared y. So x squared is a over 6, y is a over 3. So volume now is equal to a cubed over 108 cubic inches. So that is for example number 9. Now for the last example for application of maxima and minima, that is example number 10. Find the maximum area if the hypotenuse of a triangle is given. So we're dealing with a triangle. And the triangle is a right triangle. Given the hypotenuse. Say this is x and y. Now, first step, identify the constant. So the constant here is h. H is constant. Number 2, identify the variable to be maximized. Maximum area. Next, number 3. Express this variable in terms of the other relevant variables, which is x and y. So x is equal to, area is equal to 1/2 base times height. That is the area of a triangle. Now, since we have there two variables, x and y, we're looking for the other equation. That is for number 4 step. So what equation can we use that includes x and y? We have there the Pythagorean Theorem. So h squared is equal to x squared plus y squared, and that is equation number 2. Number 5, differentiate and equate to 0 the one being maximized. dA over dx is equal to 0 for maximum area. Next, differentiate equation 1. So equation 1 is a 1/2 xy. dA over dx is 0. 1/2 then x times y prime plus y times 1. Derivative of x is 1. So 0 is equal to 1/2 xy prime plus 1/2 of y, 1/2 xy prime is equal to negative 1/2 of y. Cancel the 1/2 there. Therefore, y prime is equal to negative y over x. Next, differentiate equation number 2. H squared equals x squared plus y squared. Now, remember that h is constant, so this is 0. 2x plus 2y y prime. 2y y prime is equal to negative 2x. Y prime is equal to negative 2x 2y. y prime is negative x over y. Equate y prime. Negative yx is equal to negative xy. X squared, y squared, x is equal to y. Now what is being asked again? Find the maximum area if the hypotenuse is given. So we were looking for this equation 1 here. Now to get the value of a, let's get the value of x and y in terms of each. Now if x is equal to y, then substitute equation 3, 2, 2. 2 is h squared x squared plus y squared. H squared is equal to y squared plus y squared. Therefore, y is equal to square root of h is h over square root of 2. And this is also equal to x. Finally, substitute x and y to 1. Equation 1 is equal to a is equal to 1/2 xy. So this is h squared all over 2 times. So this is square root of 2 squared. So area is now equal to h squared over, so this cancel out, 2 times 2. Area is equal to h squared over 4. And then does it have any units? None. So this is the final answer for the area for number 10. So that ends our discussion for the application of maxima and minima.